Hi everyone. So in the last video we introduced the Markov road processes and discussed the value function as a measure of long-term reward from a given state. Today we are going to go deeper into the value function and introduce one of the most fundamental equations in reinforcement learning, the Bellman equation. So the value function, from it we are going to get the Bellman equation. All right, so I think it is important we start with a revision. So the value of a state is really the expectation. We take the reward summation k from 0 to infinity, reward of sk, essentially for all the states that we are going to experience, take the rewards and with their summation, and starting with a particular state S0. Okay, by the way, in the previous video I used a small letter r, and here I'm using a capital letter, really the same thing. Okay, so I think it is important that we unroll this. So this is the expectation of rs0 plus, we have seen gamma, the discount factor. So future rewards are going to be discounted. Gamma times rs1 plus gamma to the power 2 rs2, rs3, and so on, given that the initial state is s. Okay, so we just this is just an unrolling. What I want to do is, for this time I want to remove gamma. So plus gamma. By the way, I'm writing gamma as a y here. I'm having a hard time writing gamma, so sorry for that. S1 plus gamma rs2, and then plus dot dot dot, given that we are starting at S0. Okay, so I just remove gamma here, and then there's a closing bracket here. So this is really this is an important step. For this information in the parentheses, right? This information in the parentheses, the term represents future sum of rewards starting from the next state, S1. So this is the heart of the recursive nature of the value function. So we can replace the future sum with the future of the next state. So this is it. Expectation rs0 plus gamma, value of the next state, starting we're starting at the initial state, as SS. So this is the immediate reward so the value of a particular state, take the immediate reward plus gamma times the value of the next state. This is the immediate reward. Okay, so this is gamma times the value of the next state. I think it is important for me to give you a numerical example, but before that, this is what we can do. I hope this is all right. I want to further arrange it. When we rearrange it, we can end up with reward of S0 plus, okay, sorry, Actually, maybe we can take the expectation in. So sorry, let me cancel this. So it is going to be the value of a state is going to be reward. I'm going to put the expectation in, reward of s plus expectation. So I'm just rearranging this, expectation of gamma v of s prime, and s prime depends on the probability distribution when we move from s. So s prime, here we are, the next state could be any state. It could be from s1, it could be s2, s3, or s4, for example. So s prime is just the next state. So, and it depends on the probability distribution. Okay, so I just really rearrange this and I got this. And this is the Bellman equation. This is the Bellman equation. Maybe I can write it here. The Bellman equation. All right, so I think it is important, maybe we can write this in full form. So just rewriting this so that it is much more clear. What we do is value of a state, the reward of the immediate reward, plus gamma for all s prime in the big set for all our states, probability from s to s prime times the value of s prime given, for all s small s as a subset of big S. Okay, so essentially to get the value of a state, take the immediate reward, multiply the probability to move from that state to a next state times the value of a next state, sum all the values, multiply by gamma plus the immediate reward, you are going to get the value of the next state. Okay, so I think it is important I give you an example to make it clear. By the way, I did not give you the environment that we are going to be working on. So we are going to continue with the 1D cleaning agent. This is the probability. This is the probability matrix. This is the environment. In the next video, we are going to be seeing a more robust example. Okay, so yes. So let me also be saying that gamma is going to be 0.9, and the reward of S, let's say S1, is going to be the reward of S2. I'm going to make them 0. So reward of S1 will be, let's make it 5. Reward of let's say S3 will be 10. Okay, depending on your example. So we have the full dynamics of the environment, the probability matrix, the reward, and also the gamma. So let's attempt to compute the value of S1. Let's see VSS1. But before that, usually in programming, we have to initialize give initial values to values of all the states. So V of S1, before we even compute it, let's initialize it to V of S0. Let's say V of S2 to be V of S3. I'm going to initialize all of them to 0. Okay, so now using this formula, the Bellman equation, let's compute V of S1. Well, it tells you that take the immediate reward. The immediate reward of S1 is 0. 0 plus for all the states times gamma, okay, gamma multiplied by gamma times for all the states that I can transit to from S1, take the probability that you go to that state times the value of the state. So from S1 I can actually go to S0. Well, from S1 to S0 the probability is 0.4 times the value of the value of S0, which is this, which is actually 0 plus. From S1 I can go to S1 itself. I can transit to S1. The probability is 0.1 times the value of S1 plus. From S1 I can go to S2 with the probability 0.1 times the value of what? S2. From S1 I can go to S3 with the probability of S1 to S3 0.4 times the value of S3. Okay, so essentially for all these states, take the probability to that state times the value of a state. Do this, sum them, multiply by gamma. When you do this, you will end up with 0. Okay, now for bigger examples that we have more states, the more you do this, because this is iterative. So in a for loop, for example, from S1, then you can compute the value of S2. Then maybe and S1 again and S2, because S0 and S3 are terminal states. And for bigger environments, you iteratively compute the values, and you will see that maybe from 0 you might end up in the next iteration, maybe 1 or maybe 2, and the values can converge. Okay, now think of this. We have the probability matrix, we have the rewards, we have the gamma. Essentially, we have the full knowledge of the environment. Due to this, there's actually a matrix vectorized form to compute the values in one go of all the states. And here it is. I'm trying to check it. Okay, it is V of. So V is a matrix. What we do is take the identity matrix minus gamma times probability matrix inverse multiplied by reward. So these are all matrices, and so the value is a real valued, okay, because we have ST is a real valued S matrix, and then the probability matrix, right, is a real valued S by S. These are the dimensions. Similarly, the reward depends on the number of states, right, S. And the identity matrix is S by S. This is the identity matrix. I am not going to go into how this formula is gotten, but you can check it online. Alright, so we have seen the value function from it. We got the Bellman equation, and then the example, and then the more like the matrix version. So in the next video, we are going to move to Markov decision processes. This is where we are going to formally introduce actions, which will enable us to make decisions, rather than just passively observing rewards. From there, we are going to look at policies. Once we understand policies, we are going to unlock our first algorithm, the policy iteration. So in the next video, I really plan to introduce a more robust example for the Markov decision process. All right. I hope this is clear. Let me know if you have any question in the comments. And as usual, there's going to be a Jupyter notebook related to this video. Thank you.